Hello. So in this tutorial I want to teach you about latency and about server architecture, about different type of structures that you can do, so you can understand your choices when you are architecting an enterprise application. So let's say that you have a client application running, which could be a native iOS, Android, or it could be something that runs in the browser, in the client browser. Then this client browser, it will, when it connects to the server, before it connects to the server, will have the URL that will specific, the corresponding URL that will make the request to the server. But before that, it will make a DNS call. Then maybe you can have a CDN in the middle, and only after you have, let's put it here, a server architecture of your data center, or let's put it here, data center A, where in here then you can have a load balancer, and you can have the server A, the server B, and the server C, something like that. And then below here you can have databases or other servers, whatever. So for now, let's just keep this as it is. So just so you can understand, every time that you make URL requests, the client will make a call to the DNS. The DNS we are talking about is just one round robin request. So it could be between around 10 milliseconds, and then you get from here, you get the correspondent IP. So this returns the IP. You can always configure the DNS based in geolocation or based in weights. So basically you can say that, okay, if the user, the client IP, if it comes from some part of the world, returns the IP of some CDN or returns the IP of some data center. Otherwise, if it comes from other parts, it returns the correspondent IP from some other data center. Or it could be based in weight, saying that for 40% of the requests that the DNS receives, return IP from data center A. 60% return the IP from data center B. So something like that. You can have multiple different percentages, whatever. Okay, the idea here, what I wanted to show is that every time they make a request, a URL, first you waste 10 milliseconds to get the correspondent IP, and then you make the request to that specific IP. So let's say the IP will be a CDN. So what is a CDN? So a CDN is a content delivery network, where basically this is like for caching. Basically is data cache. Is a network that basically caches results. So when the client, instead of the clients, then all this process pass through to the data center, and the servers connect with the databases, process that request, returns it to the clients. Imagine that you already have that data cached to the client, so the client can get that cached data much faster, and so this is like very fast. So we are talking about around 150 milliseconds. So basically a CDN, it is a private network. You have multiple types of network. You have multiple types of different private networks. You have the Amazon, you have Akamai, and you have other ones, where basically they have load balancers, they have multiple different servers, and blah blah blah. basically is a private network of servers that are configured for high availability and highest performance to return cache in a very fast way. Okay, so this CDN we can configure it to point to the right data center. So let's say that the specific data is not cached yet, so the CDN will not return. It will pass to the next layer, which will be to forward the corresponding request to the right next nodes. So this is not DNS, so the DNS it will return the IP to the client, and then the client makes a request to CDN. In this case, CDN it will not return any IP, so the CDN will simply forward the request to the next nodes. So attention with the DNS that I forgot to tell you, don't forget that then we have the cache in here. We have the cache, and also we have DNS authoritative, which is the real DNS servers, and then you have the routes that also cache the DNS. So when you get for a DNS, when you request for the IP of a specific domain, maybe that doesn't mean that you will hit the real authoritative of the DNS server. Basically what it means that you get IP, but maybe that IP could be cached in some nodes in the network. So be careful with that. So we need to pay attention with also the caching. And also this caching, then it will make the cache to the client. So the client, if you make 2 requests, after you get the first DNS for the first request, if the domain it is the same, you'll not make a second request to the DNS, so the client will cache this IP for the next requests, obviously. Okay, so just keep in mind this. Okay, so then, as I was saying before, so CDN, you can configure CDN to point to the right data center, to the next server, to the next to the next nodes in your architecture. So you can configure the CDN to point to the right data center, based in geolocation, or based in metrics, or based in scripts that you create and that CDN prefetch to know the status of your data center / server, whatever you want to call it, your server architecture, internal server architecture. So there are multiple ways of configure this. So you can do it based in weights also. So there are multiple ways of configure CDN. So base CDNs is load balancers and servers. So everything that you can do in load balancers, you can do also in CDN, depending of the service that you hire. It depending obviously what are the functions that these providers make it available. But usually everything that you can do that you can configure in your server, you can also do it in your CDN. Okay, so then CDN forwards this to the specific data center. So imagine that you can have data center A, then you can have the data center B. So CDN may decide what is the data center that you can forward. So another thing, if you don't have CDN, you could do it through the DNS, saying that if the geolocation from some IP is south of my country, goes to data center 1, otherwise goes to data center B, or based in weights. 40% forwards to data center A, 60% forwards to data center B. So the logic it is very similar. Okay, CDN is simply because it is an extra layer that gives you more flexibility and is very fast. Okay, so currently we have here the correspondent milliseconds, and then when this gets to the data center A, then it enters in your internal architecture, where you can have just one load balancer that will do the load balancing to your servers. There are multiple different types of balancing that you can do. You can do round robin, you can do based on percentage. There is a bunch of things that you can do. Different type of algorithms, balancing algorithms. You can search that on the web. Okay, so then the request gets forwarded to the specific server, and then so round robin, or it could be based in scripts also, the metrics. There is a bunch of things that you can configure this. So then the request gets redirected to the corresponding server. The server applies their own logic, and it may connect or not the database, and the database maybe has some cache or not. Even the service may have some cache or not. So there are multiple different things that we can do here. Additionally, let's say that in the data center B, instead of having just one load balancer, let's say that we have like some web server type, where basically what you'll do is redirect the requests. So the request will be a simple URL which have a domain, a path, some query string, whatever, and basically the web server, it will redirect this URL to the load balancer 1 if it is the URL is if it contains a specific type of string, and otherwise it may redirect to the load balancer 2 if the URL contains some other string, whatever. So A, B, C, D, E, F, or could be just like this. This is just an example, where then the servers can talk with each other also. Basically, let's say that the server A may talk with the server D also, and the server D may talk with the database, or instead of the database you can have parallel layers in here, which basically could be caching layers or queue layers, saying like with cache let's say that you have mem cache D, or you have Redis. On the queue you may have Rabbit, a server with RabbitMQ or Kafka, or you can even connect with a third-party service for queue. Amazon always also have the service for this. I'm not remembering what is the service, but it also has a service to save memory data also. So there's a bunch of things. So for the database you can have SQL databases as like MySQL, Postgres, SQL Server, Oracle, Sybase, MariaDB, whatever the database is. Or you could have non-SQL database as MongoDB and other ones. This is an example. So these are documental databases, documental data storages. So then you can have all these servers connect with all these layers. What the protocol? So for the queue you're gonna use the AMQP protocol, as I explained before. For the Redis, this will be a TCP connection. Is not any specific. There is not a protocol specifically. It is a TCP connection to Redis. Memcache the same thing. AWS, it is an API, so you need to see how to connect with the correspondent services. You should download the correspondent libraries to connect it easier. For MongoDB, for the database, you have it is a database connection, so you have the drivers. You need to have the drivers, the correspondent drivers for all of these. Also in here, the correspondent drivers. But basically, what I'm saying is that all of these you have delays. So there is a good thing to have this, and this then in the database and in caching layers like Redis. You can have masters and slaves, and also you can have clustering, which is sharding, if I'm not mistaken, that's the right term, sharding. So in all of these type of architectures, you can have that to be faster. Where you the master, you write on the master, you read from the slaves, when automatically every time that you write something in the master it will synchronize that things to the slaves. Then you can have all these architectures talk also and be synchronized with some other databases and some other data centers also. So there are multiple ways of you can then organize all your server architecture based in delay time. So don't forget that, and this is an important thing, which is so for websites performances, or not, let's not call it websites, let's call it clients apps return responses, like to see websites and whatever performance. This should load between 2 to 3 seconds. So a good app that is optimized should load in 2 to 3 seconds. So basically, if you have, as you can see in here, you only expand, like, even if this takes more time, we are talking about, because this is a TCP, well, as a matter of fact, this 150, this is for the TCP connection, but in here you have more than, this is for the TCP handshake, in here you do more than one TCP connection. So I'll say that in here, I'll put here, if it is, let's put it here, 300 milliseconds, around that. So you already have in here expand around 300 milliseconds. Then you need to enter this in the data center. If you have web servers, then to redirect to the specific load balance. So all of these you have latency. So in here for the web servers, what you have, you can have Nginx, you can have Apache, depending, you can have Tomcat, you can have HA proxy, whatever. For the load balancing, you have multiple different types of load balancings, but you have HA proxy, it is a very good one. So how do you connect? So let's say that's in the queue also. Not only here, I said that you can have this master and slave database in cache, but you can always have a type of structure, a load balancing structure in the queue layer also. So in the queue layer, you may have load balancers also with server A, with server 2, whatever, server 1 and server 2, whatever. You can always have also this. And the protocol that, and in this case the load balancer will be HA proxy, or I will advise you to use HA proxy. So as I was saying, for the queue, so you can have another structure like where you have load balancers also, the server 1, server 2, to receive the specific queues, and then to connect with the specific servers. Basically to register the queues, to parse and to dispatch the correspondent workers in the specific queue, where in this case will be the server D, E or A, B, C, whatever, that will connect with this load balancer, passing the correspondent workers, and then will be listening until these servers dispatch these specific workers to the correspondent servers. So this is just an example, architectural example, that's things that you can have. More. So I think that's, let me give you, so we can do here a practical example in here. So let's say that, don't forget this is very important. Well, basically you don't want a website to load less than this. Of course, you always want a website or an app to have the data ready to show to the clients as fast as you can, obviously, but 2-3 seconds, it is the standard that if you are that most of if I'm not mistaken 80 something% of the websites in the web that are acceptable, or to certainly it is the standard that is acceptable to load things in the web to the user. Usually this is the standard. So as you can see, you have if you can optimize your system to have this is a very important thing. Okay, so what we can, before I give you real example, let's talk about two other things, which are certifications. So TLS and mtls, and then let's talk also about session sticky, because sometimes this could be a problem. And so let's talk about session sticky. So session sticky, for DNS it doesn't make any sense. For the CDN, before I explain this, let me explain what is the purpose of session sticky, and maybe I'll explain this in a much simpler example, like load balancers to servers. So let's say that this load balancer has the session sticky active. This means that the requests that he receives from above, from the client, from the CDN, whatever, when the load balancer forwards these requests to the correspondent server, it means that the next requests that you get from the same origin, from the same client, CDN, whatever, it will forward to the same server. So session sticky, it means that the requests below in the direct lower architecture, it will be the same, it will be redirect always to the same endpoint. Basically that's what means session sticky. So let's say that in CDN you configure the session sticky. It means that for the CDN, let's say that the CDN will forward this request based in whatever, some scripting which is based in some metrics of both data centers, data center A and the data center B. So let's say that if you have a session sticky that will forward the client's request to the data center A, even if the data center A, even if it is overloaded, the next request will be always forward to the data center A until the cache expires. So be careful with that. Then when it enters in the correspondent data center, the request will be forwarded to the load balancer. In this case it will be first to the web server. If you have session sticky in this web server, it means that if you, in this case doesn't make too much sense, because this web server is working, the redirect is based in the URL. So in this case the purpose will be load balancers. So if you have then the session sticky active for the correspondent load balancer 1, it means that when the request arrives to the server A, if the other request from the same client arrives here, the request will be always forwarded to the server A, and like this. And then if you have round robin here, the next client's requests, not the same, another client, will be request to the server B, but all the requests from client B will be redirected to the server B. So session sticky, it means exactly this. The same thing here in the queue. If you have session sticky active in your HEA proxy, it means that automatically if some server D connects to the queue to register some worker, and this load balancer forward to the server 1, it means that server D to only talk with server 1. Basically this is the concept of the session sticky. Now when you have TLS or mtls, the problem is, let's say that you have a connection between the client and the CDN with mtls, or let's make it simple as TLS. So the way that TLS creates session sticky, it is based in cookies. The way that mtls creates the session sticky is based in the certificates client's ID. So basically when you have the handshake of the mtls, basically each connection will have a specific ID. The client will have a specific ID. So this ID, that's what the load balancers use to create the session sticky, because the request, so in here, so in mtls they don't see the HTTP headers. They don't see the headers request. Basically what they see, it is the certificate headers, but they don't get to see the HTTP request, so they don't get to see the cookies first. So in TLS they have access to the cookies, but in MTLS they don't have. So first this connection is made through the certificate client ID, and only after then the endpoint of this MTLS, the endpoint, then it will, that's what it will then decrypt the specific data, and then it will have access to the corresponding cookies. So let's say that you have session sticky in some load balancer through the MTLS. So at this load balancer, it will not see the specific requests data. It will not see the HTTP headers. What is doing here is doing the session sticky through the certificate client ID. That's what it sees. When this request gets to the corresponding server, then this server, it will decrypt the information, the request data, and only after it will check, only after it can execute, it can perform the corresponding actions based in the data that it receives from the corresponding request. So this is that's the main difference between MTLS and TLS. So TLS, it works, so the load balancer automatically in here with TLS, it can see the HTTP headers, it can see the cookies, so it can forward this based in the cookie session sticky ID that he created when it receives the first client request and when it performed the first redirect to the server D. So imagine like load balancer as like a cache storage system, where on the first request it creates a session cookie for the session sticky. That this session cookie will be in the cookies of the clients, who send them then to when the first request responds to the clients, it will have all that cookie. So the next request, it will receive always that specific cookie, that the load balancer then it will read that cookie and will know, oh, okay, so this cookie I have in my own local storage, in my memory, that I need to forward this to server D, and automatically forwards this always to server D. In MTLS, it is not done through cookies, it's done to certificate client ID, where is the same thing, that the load balancer saves in memory this specific client ID based in the corresponding certificates, and well, I'm saying certificate, but it's not really the certificate. It's like an ID that the load balancer creates based in the client certificates that he receives when creates the MTLS handshake. So after that, you'll always have that specific client ID. And then based on that memory storage data, he knows, okay, this client ID, this certificate client ID, I need to forward to the server E. So that's basically how it works between these two different forwards. So let's say that the client sends a request to a CDN, and we have TLS or MTLS configured. So what happened then when the CDN forwards the requests to the correspondent data centers? So what happened is that, so we have clients, we have TLS or MTLS configured on the CDN, and then CDN suddenly redirects this to the data center. So or you don't have any TLS here, you don't have, so let's say that all of this works in HTTP. Or the connection, it will not be done through HTTPS, so here will be simply HTTP. Or if you want to have here HTTPS, or you have the TLS protocol, or you have the MTLS protocol. Now, these certificates here, this handshake that you have here, is not the same handshake that you have here. Or the CDN is a CDN pass-through, where basically it only works as to forward that specific request. So it's basically, but in this case, if it is TLS, it might make sense, but if it is MTLS, it doesn't make sense to be passed through. Why is that? So let me separate this so you can understand this better. So basically, when the client has a TLS handshake with the CDN can simply check if it is cached, if it is the request, if it is cached. If it's not, can forward with the same TLS certificate. So we can put here same TLS certificate to the correspondent data center. Because why? Because the CDN can see the HTTP headers, can see the headers, can see the cookies, can see the URL, so you can see a bunch of information. So the CDN can act accordingly and can make the correspondent forward. The same thing that when we get here to the data center, so let's say that we have here ALB. So when we forward this to the server A, example, so in here we may have, if we want to have again the same type of connection, in here we will have the same TLS. So the TLS will only be decrypted in the server A. So decrypted TLS. The decryption will only be done in the server A. Now, when you have this in MTLS, in order to have, this is very interesting, because in order to have this, so this is, so the correct way to do this is, in here you need to have the MTLS A with a specific certificate between these two, then you need to have another certificate between these two. So this is not the same, this will not be the same MTLS, this will be MTLS B, example. And then in here, depending of the configuration, in this case this should be a pass-through load balancing, where in here then you could decrypt the MTLS. Otherwise you need, I think if I'm not mistaken, you need to have also here another MTLS handshake also between ALB and the correspondent server. So this is just to explain to you the configurations of this. So this is like so you can understand, depending of the security that you want to have in your infrastructure, you need to be sure about the concerns about the management that you may have, because then you need to have all these configurations, and more configurations that you do, more risk that you have, more latency that you have. So you need to pay attention to all these concerns then to make the correspondence to make the correct decisions. Don't forget that inside of your data center, maybe only these will be on a public network. So it will be public, but all of these will be on a private network. So don't forget that if you want to have between these web servers and the other private networks, if you want to have HTTPS connections or TLS TCP connections, either way, you need to be careful, because all these connections you have more latency. And don't forget that this is already a private network. So the user to maybe doesn't make too much sense in a lot of different cases. You need to analyze your own scenario, obviously, but maybe it doesn't make sense. And in here you don't need to have TLS. Even when you connect like server A to your queue architecture, maybe you don't want to have TLS. Maybe it doesn't make sense. Maybe when you connect TCP with the database or a third-party, with third-party APIs, it makes sense. But if you are connecting two servers, so my point is, if you are connecting two servers in your private network, maybe it doesn't make sense to have all the security layers to make this a little bit slower, because if you want to have if you want to make the system faster and with less buggy also, you need to put all of these criteria, all of these things in your balance, you know, so you can understand what exactly what you are able to allow or not, you know. So you need to think about all these key factors. So yeah, so basically this was related with the TLS things. Additionally, the idea always in the let's say that in here you have multiple different levels of layers. In here I put this like this, where it looks like you have first layer, and then you have a second layer where server A talks with server D, or these servers talk with these servers, and these servers talks with these other servers, whatever. It could be one architecture example, but also you can have all of these in parallel layers in here, where all of these can talk with all of these other servers. So what I want to explain next is caching. So most of these things, so for mostly data that comes from databases, relational, non-relational, SQL, non-SQL databases, if you can have cache, you should always have cache. So the servers, though, they don't need to connect with the database, because every time that you connect with the database you have latency, you have threads that gets blocked. Even if you don't talk with database, let's say that you are talking with some input and output file pointers, where you want to read and write something in the file systems. So all of these actions basically to block for a certain period of time, milliseconds obviously, your process. And sometimes you need to think about synchronous and asynchronous processes also, but you also need to think about cache, because cache is much faster. So then you do a read or write in the database, file system, whatever. So in order to do that, you can always use memory. You can always use cached in memory, or in a system like Redis, which could be also persistent. You can configure, although Redis you can have a memory server, or you can have multiple Redis servers, master slaves, partitioning Redis in multiple data, partitioning in different servers. You have multiple different configurations that you can do. You can always do this also persistent. So every time that Redis dies, when it starts again the next time, automatically it will load the previous state that he has saved in the file system. So all of that is also possible to configure. My point is, always try to have cache in your logical layer, in your logical servers, in the servers that contains the logic codes. You should always to have cache. So you have less latency and less blocks. So the threads. So if you have a system where you have threads, so you want to have to dispatch that threads as soon as possible. You want to return the result very fast. So if you have less connections, better, because every time that you connect to here, you have a TCP connection. A TCP connection, first you'll have the handshake. The handshake, as I explained before in the previous server, the handshake, and in here also, the handshake is 150, between 100, well it varies, but it could be between 50 to 150 milliseconds. So there is always latency, more requests they do, so you need to think about this, about what is the end result, the performance of your server, what is the end result that you really want. So then another thing that I just talk in a very high level. Now I can detail a little bit better, which are sync vs async requests. So why do you should use and one thing that we can talk is, so database requests, cache requests, these are synced requests. Databases requests which are synced are blocking. Everything that is sync requests, it's a blocking request. So it takes time, so you need to wait until you get the response from here. Depending of the state from here, then you are waiting from here. Although you can always have connection timeouts and all of that things that you can avoid in code and that you can cover in codes. You can have the plan B, the plan A, the plan B, the plan C. In case if this fails, I do this and that. Obviously, you should always do that. What you should do then is you should always first do the sync request, TCP sync request to your cache. And in here, so it's much faster than in here. Also, you should have the connection timeouts and all of that failures cover in your codes. Now, but let's say that we are talking about not about database and caching, but let's say that we are talking about calling external APIs or executing some processes that they don't need to run synchronously. So let me talk about, let's say that you have some thing that you need to send an email. Let's say that the user did, so your server did some logic codes to do something. Let's say that it was a user registration, where you save that registration to the database and now you need to send the email to the user. You should not send the email, the action of sending the email should not be inside of the correspondent logic. It should be inside, but it should not be a synchronized blocking request, because you don't want to be waiting to connect with the SMTP protocol to the SMTP server, which could be on premises in the same network, or it could be on the third-party network, whatever. But so you don't want that. So you want to have that request in a asynchronous logic code. So how can you do that? That's where it enters the queues. That's where it enters RabbitMQ, Kafka, AWS SQS. So that's where it enters all these type of technologies. Basically, these are simply queues. So imagine this as like a thread pool where you can basically register. You can register workers. Basically, you can register names and specific data to specific lists. So you can create lists. You can create multiple thread pools. So each thread pool corresponds to a specific list, and then you will insert specific workers into that thread pools, and automatically, which in this case will save that in an internal list, and then they have their own thread pools. Then to get these elements inside of that list, these workers, and automatically to dispatch them. So basically then what will happen is that in here you will launch an asynchronous request to register a worker in here, and then in here automatically it will launch a worker, but at the same time in some other server you have also a listener. A listener basically in here that will be waiting for the answer of this guy. That basically this guy will only answer to that specific listener, saying that okay, now I'm parsing the queue, and when it gets to that worker that you register, I'll let you know, basically. And when it gets to that, when that thread of pools parses that specific list, then it will alert, it will notify the correspondent server that's okay, I already dispatched this specific worker, so please execute your specific listener. So in your listener, I will notify your listener, so you can then execute and perform whatever the actions that you need for this specific worker. That's how it works. So then this listener has like, for this specific worker, I want to execute these actions, like which will be sending the emails, connect with the SMTP server. Then I can only say then this action, it will return a status. Let's say that the SMTP server, it will be down or is super overloaded. So in this case, it will return the status, the status false to the queue again, and the queue will put the worker again in the list, and to continue parsing all the other workers, and when it gets to that specific worker again, it will trigger again the correspondent listener in the server. So, and we can configure the specific list to do this like 5 times. When it reaches to that 5 times, it can save that specific worker in a dead letter, which will be is a persistent storage with the failed workers. But attention, that is not a permanent persistent. So after a few days, that file, it will be deleted. So one of the things that I'll advise you is, when that happens, please save that in another database. So what I'll advise you is save this type of things in MongoDB. So this basically is the difference between synchronous and asynchronous requests. Don't forget, synchronous, it is blocking. It means more latency. You are waiting. So if you can create a system where you have multiple things like asynchronous, it is much better. So let's say that in here in server A does the logic inside of server A does the logic 1, then the logic 2, then the logic 3 sequentially. But let's say that these logics, they don't need to be sequentially. So maybe you can use these as threads. You can launch 3 threads. Each thread, it will execute the logic 1, 2 and 3. And then when all the logics finished, then you wait at the end of the process of the server A, and when all these logics get done, then that's when you release and you return the correspondent response above to the client, to the layer above. So that's if you do this, you'll see that the latency will be much lower and the speed will be much faster. So that's what I want you to show you, is that synchronous and asynchronous, all of these concepts, it will influence the way that you build your application, your logic application.